Far beyond the outer planets, beyond Neptune, beyond the known boundaries of the solar system, there is a spacecraft still moving through the dark. It was never meant to last this long. Launched in 1977, Voyager 2 was designed for a mission of just a few years to explore the outer planets and send back data before fading into silence. But it never stopped. Decades later, it is still transmitting, still moving, and still sending information from a region of space no spacecraft had ever explored before. And recently, after a brief and unexpected loss of contact, Voyager 2 came back online. But when it did, the data it returned revealed something unusual. Not a signal in the traditional sense, not a message, but a pattern, a subtle, persistent vibration in space itself. Something scientists describe not as a sound we can hear, but as a kind of background hum. The silence that was never empty. To understand what Voyager 2 detected, we first need to understand where it is. Voyager 2 is no longer in the solar system as we define it. It has crossed a boundary known as the heliopause. This is the outer edge of the sun's influence, where the solar wind slows and gives way to the interstellar medium. Beyond this boundary, space is different. It is not empty. It is filled with thin gas, charged particles, and magnetic fields that stretch across the galaxy. For a long time, scientists assumed this region would be quiet, a kind of cosmic void. But Voyager 2 showed that assumption was wrong. Space beyond the solar system is active, structured, and constantly moving. The loss of contact. In July 2023, something unexpected happened. Voyager 2 stopped communicating with Earth. A command sent from NASA caused the spacecraft's antenna to shift slightly away from our planet. The change was small, just a few degrees. But at a distance of more than 19 billion kilometers, that was enough to break the connection. For weeks, Voyager 2 was silent. No data, no confirmation, only the knowledge that somewhere in interstellar space, the spacecraft was still moving, still operating, but no longer speaking. Then, in August 2023, NASA regained contact. A faint signal was detected, weak but unmistakable. Voyager 2 was still alive. The return of data. When communication was restored, Voyager 2 resumed transmitting data. And that data contained something important, not something dramatic. Not something unexpected in a sensational way, but something deeply significant. Measurements of plasma waves in interstellar space. These are not sound waves in the way we experience sound on Earth. There is no air in space, no medium for sound to travel as we know it. But there is plasma, a mixture of charged particles. And within that plasma, waves can form. These waves carry information about density, movement, and energy, and when converted into audio frequencies, they can be interpreted as sound. A kind of translation, a way of hearing what cannot be heard directly. What Voyager 2 detected was a persistent pattern in these plasma waves. A steady signal, not random noise, not silence, but a continuous background presence. Scientists had seen similar data before, but this time, the pattern appeared clearer, more defined, more consistent. It suggested that interstellar space is not quiet. It has structure, movement, energy. This hum is not a sound in the traditional sense. It is a representation of activity, a signature of the environment beyond the sun's influence, and it reveals something important. Interstellar space is not empty. It is alive with motion, a region between stars. Voyager 2 is now traveling through the local interstellar medium. This is the space between stars, filled with extremely low-density plasma. Magnetic fields stretch across vast distances. Particles move, waves form, and energy flows. The hum detected by Voyager 2 is a reflection of these interactions. It is the result of plasma oscillations, tiny fluctuations in density and pressure that propagate through space. On Earth, we experience waves through sound and water. In space, waves exist in plasma, and they tell us what is happening in regions we cannot directly observe. A discovery that changes perspective. For decades, space beyond the solar system was imagined as silent. But Voyager 2 has shown that this is not true. There is motion, there is structure, there is energy. The hum is not mysterious in a supernatural sense. It is not a signal from an unknown source. It is the natural result of physical processes. But it is still remarkable because it reveals that even the emptiest regions of space, the importance of listening Voyager 2 is not just sending images. It is not just mapping planets. It is listening, measuring, recording, and translating the environment of interstellar space into data we can understand. The plasma wave instrument on Voyager 2 is one of its most important tools. It allows scientists to detect changes in the density of interstellar material, to observe waves, to understand how space behaves beyond the sun's influence. And through that instrument, we are able to hear the universe in a way that was never possible before. A signal from the edge of the solar system. The fact that Voyager 2 is still operating is remarkable. The fact that it is still sending usable data is extraordinary. But the most important thing is what that data represents. A direct measurement of interstellar space, not from a telescope, not from theory, but from within the environment itself. Voyager 2 is there, and it is telling us what it finds. The beginning of a new understanding. The hum detected by Voyager 2 is not the end of a mystery. It is the beginning of a deeper understanding. It tells us that space between stars is not silent. That even in the vast emptiness beyond the solar system, there is motion, there is activity, and most importantly, it tells us that we are only beginning to explore it. Because Voyager 2 is just one spacecraft, one point of data, moving through an immense region that we have barely begun to study. Somewhere more than 19 billion kilometers away, a spacecraft continues to travel. It has no destination, no final objective, only motion and communication. And as it moves further into interstellar space, it continues to send back something unexpected. Not silence, but a signal, a pattern, a subtle, persistent reminder that even the emptiest regions of the universe, they are filled with motion, with energy, with something we are only just beginning to understand. What Voyager 2 detected is not a sound in the way we understand sound on Earth. There is no air in interstellar space, no atmosphere to carry vibrations to an ear. Space, especially beyond the heliopause, is filled with plasma, a thin mixture of charged particles made up of ions and electrons. And within that plasma, waves can form. These are known as plasma waves. They are not sound waves. They carry energy. They move through a medium. When Voyager 2 detects these waves, it is not hearing sound. It is recording variations in electric fields caused by oscillations in plasma density. Those measurements can then be converted into frequencies we can hear. What we call a hum is simply a translation of those frequencies into human perception, turning space into sound. The process of converting plasma data into sound is both scientific and interpretive. Voyager 2's plasma wave instrument measures tiny fluctuations in voltage. These fluctuations correspond to changes in the density of plasma around the spacecraft. Higher density creates higher frequency oscillations. Lower density produces lower frequencies. Scientists take this data and scale it into the range of human hearing. The result is what we perceive as tones. The hum is not an artificial creation. Yet it is a representation of real physical conditions in interstellar space, a direct translation of motion into sound. And what makes this important is consistency. Because Voyager 2 did not detect a single burst, it detected a persistent signal. The difference between Voyager 1 and Voyager 2. Voyager 2 is not alone. Its twin, Voyager 1, entered interstellar space earlier, in 2012. Voyager 1 also detected plasma waves, but the data from Voyager 2 is different. Because the two spacecraft are traveling in different directions, they are sampling different regions of interstellar space, and those regions are not identical. Voyager 1 detected sudden increases in plasma density, often associated with shock waves from solar activity. Voyager 2, however, has measured more gradual, continuous variations, a steadier pattern for a more persistent background signal. This difference suggests that interstellar space is not uniform. It has structure. Different regions behave differently, and the only way to understand those differences is through direct measurement. A medium that carries information. The plasma surrounding Voyager 2 is incredibly thin, far thinner than anything we experience on Earth. But even at such low densities, it behaves as a medium. It carries waves. It responds to energy. It interacts with magnetic fields. This is what allows Voyager 2 to detect patterns. The hum is not a signal being sent. It is a property of the medium itself, a result of motion, pressure, and electromagnetic interactions. In a sense, it is the natural state of interstellar space. Not silence, but activity at a scale we are only beginning to measure. Of the role of magnetic fields. Magnetic fields play a crucial role in shaping what Voyager 2 detects. The interstellar medium is threaded with magnetic fields that extend across vast distances. These fields influence how plasma moves. They guide charged particles. They shape waves. When plasma interacts with magnetic fields, it can create complex oscillations. These oscillations contribute to the patterns Voyager 2 measures. They are part of the hum, but they are not random. They follow physical laws. They reflect the structure of space itself. And by studying them, scientists can map regions that cannot be seen. Signals from solar events. Even though Voyager 2 has left the solar system, it is still influenced by the sun. Not directly, but through events that propagate outward. When the sun releases bursts of energy, such as coronal mass ejections, those disturbances travel through space. Eventually, they reach the interstellar medium. When they do, they create shock waves. And those shock waves interact with the plasma around Voyager 2. This can temporarily change the hum, creating spikes, changes in frequency, variations in intensity. In this way, Voyager 2 is not just measuring interstellar space, it is also detecting echoes of activity from our own star. A new way of observing space. Traditionally, astronomy has relied on light, visible light, infrared, X-rays. But Voyager 2 represents something different. It is not observing from a distance. It is measuring from within. It is experiencing the environment directly. And that allows for a new kind of data. Not images, but interaction. Not observation, but presence. This is what makes the hum so important. It is not something we are seeing. It is something we are detecting from inside the system itself. The meaning of the pattern. The most important aspect of the hum is not that it exists. It is that it is consistent. Consistency means structure. Structure means underlying processes. And underlying processes mean that interstellar space is not random. It is governed by rules, by interactions that can be studied, modeled, understood. The hum is not a mystery waiting to be solved. It is a signal that we are beginning to understand how space behaves beyond the solar system. The beginning of interstellar science. Voyager 2 is doing something no spacecraft has done before. It is conducting science in interstellar space. Not from afar, but from within. Every measurement it sends back adds to a growing picture. A picture of a region that was once completely unknown. And that picture is changing how we think about the universe. Because if interstellar space has structure, if it has waves, if it has patterns, then it is not empty. It is a dynamic environment. And we are only beginning to explore it. The hum Voyager 2 detected is not a message. It is not something artificial. It is not something unexpected in the sense of breaking the laws of physics. But it is still remarkable, because it represents something we have never directly experienced before. The sound of space itself. Not as we hear it, but as it exists. A translation of motion into frequency. A reflection of a medium that we are only beginning to understand. And as Voyager 2 continues its journey, that hum will continue, changing, evolving, revealing more about a region of space that was once completely silent to us. What Voyager 2 detected is not a message. There is no transmitter, no origin point sending information across space. And yet, the signal exists. A steady pattern, a measurable presence, something that behaves like a background layer of activity, always there, always detectable, always part of the environment. This changes the way we think about space, because for a long time, silence was the assumption. Space was imagined as empty, a vacuum where nothing happens unless something moves through it. But Voyager 2 has shown that even in the vast regions between stars, there is motion, there is structure, there is something that can be measured, translated, and understood. And that realization is more important than the signal itself. The end of the empty space idea. The idea of empty space has always been misleading. Even in regions far from stars, space is filled with particles, fields, and energy. The interstellar medium, where Voyager 2 now travels, contains plasma so thin it is almost nothing, yet still enough to carry waves. These waves are not visible. They are not something we can feel, but they are real. They move through space. They interact with magnetic fields. They respond to energy. The hum is simply a reflection of that reality. It is not something new appearing. It is something that was always there. We just never had a way to detect it before. A spacecraft that became a listener. Voyager 2 was never designed to search for something like this. Its primary mission was planetary exploration, to visit Jupiter, Saturn, Uranus, Neptune, and then, eventually, continue outward until its systems failed. But what makes Voyager 2 extraordinary is not just what it was built to do. It is what it continues to do. Decades after launch, with limited power and aging systems, it is still collecting data from a region of space we have never directly studied before. It has become something more than a spacecraft. It has become a listener, a device measuring an environment that no human has ever experienced. And through that listening, it is translating something we cannot perceive into something we can understand. The first step into interstellar exploration. Voyager 2 represents something larger than its mission. It represents the beginning of interstellar exploration. Not travel in the sense of reaching another star, but presence, measurement, understanding. For the first time, humanity has an object operating beyond the boundary of the solar system, not observing from afar, but existing within that environment. And that changes everything. Because it means interstellar space is no longer theoretical. It is measurable. It is real in a way that can be studied directly. The hum is one of the first pieces of that data, one of the first direct experiences of what exists between stars. What comes next, Voyager 2 will not last forever. Its power comes from a radioisotope generator that is slowly losing energy over time. Each year, systems are turned off to conserve power. In the coming years, its instruments will go silent. And eventually, the spacecraft itself will stop transmitting. But its journey will not end. It will continue moving through interstellar space, silent, invisible, carrying with it a record of human existence. But more importantly, it will leave behind something else. Data, measurements, a foundation for future exploration. Because Voyager 2 is only the beginning. Future missions will go farther, with better instruments, more advanced systems, and a deeper understanding of what to look for. The meaning of the hum. The hum, Voyager 2 detected, is not mysterious in the way people often imagine. It is not a signal from an unknown source. It is not something that defies explanation. It is the natural behavior of plasma in interstellar space. But that does not make it less important, because what it represents is far more significant than what it sounds like. It represents a shift from imagining space to measuring it, from assuming silence to detecting structure, from observation to presence. The hum is not the discovery itself. It is the evidence that discovery has begun. A universe that is never still. What Voyager 2 is showing us is simple but profound. The universe is not still. It is not silent. It is not empty. Even in the spaces between stars, there is motion. There is interaction. There is something happening. And that changes how we see everything. Because if even the most distant regions of space are active, then there is no true emptiness. Only scales of activity we have yet to measure. A new way of understanding reality. For most of human history, space was something we looked at. A distant backdrop. A place filled with stars, but separated from us by unimaginable distance. Voyager 2 changes that perspective. It brings space closer, not physically, but scientifically. And it allows us to experience a part of the universe that was once completely unreachable. And through that experience, it changes our understanding of what space is. Not a void, but a medium. Not silence, but motion. Not emptiness, but structure. The final realization. Voyager 2 did not discover something that suddenly appeared. It revealed something that was always there. The hum was not created, it was uncovered. And that is what makes it powerful. Because it reminds us that the universe is not defined by what we know. It is defined by what we have yet to discover. And every new measurement, every new signal, every new observation brings us closer to understanding a reality that is far more complex than we once believed. A signal that never ends. Somewhere, more than 19 billion kilometers away, Voyager 2 continues its journey, moving silently through interstellar space, still transmitting, still measuring, still listening. And as it moves farther from the sun, deeper into the galaxy, the signals it sends back will continue to change. The hum will evolve. The patterns will shift. The data will grow. And with it, our understanding will grow as well. Because this is not the end of the story. It is the beginning. Voyager 2 was never meant to last this long. It was never meant to reach this far. And it was never meant to listen to the space between stars. But it did. And in doing so, it revealed something fundamental. That even in the most distant, quiet regions of the universe, there is something there. Something measurable. Something real. Not silence, but a presence. A subtle, continuous reminder that the universe is never truly empty.